In this video, we'll learn how to solve homogeneous linear differential equations with constant coefficients. We'll use the same method every time and solve 5 different types of problems step by step. The key idea is to try a solution of the form y equals e to the rx. This turns derivatives into powers of r and gives a characteristic equation. Let's outline the method. Example 1. Distinct real roots. Solve y double prime minus 5, y prime plus 6, y equals 0. We substitute y equals e to the rx and get the characteristic equation. R squared minus 5, r plus 6 equals 0. Factoring gives r equals 2 and r equals 3. So the solution is c1 e to the 2x plus c2e to the 3x. Example 2. Repeated root. Solve y double prime minus 4, y prime plus 4, y equals 0. The characteristic equation is r squared minus 4, r plus 4 equals 0. This is a perfect square, so r equals 2 is repeated. With a repeated root, the solution is c1 plus c2x times e to the 2x. Example 3. Complex roots with 0 real part. Solve y double prime plus 4, y equals 0. The characteristic equation is r squared plus 4 equals 0. So r equals plus or minus 2i. Complex roots of plus or minus b, I give e to the ax times cosine and sine terms. Here is 0, so the solution is c1 cosine 2x plus c2 sine 2x. Example 4. Complex roots with a negative real part. Solve y double prime plus 2, y prime plus 5, y equals 0. The characteristic equation is r squared plus 2, r plus 5 equals 0. Using the quadratic formula, r equals negative 1 plus or minus 2i. So the solution is e to the negative x times c1 cosine 2x plus c2 sine 2x. Example 5. A third order equation with a repeated root. Solve y triple prime minus y double prime minus y prime plus y equals 0. The characteristic equation is r cubed minus r squared minus r plus 1 equals 0. Factor by grouping to get r minus 1 times r squared minus 1, which is r minus 1 squared times r plus 1. So the roots are 1, 1, and negative 1. The solution is c1 plus c2x times e to the x plus c3 e to the negative x. Let's summarize. For homogeneous linear equations with constant coefficients, we always try y equals e to the rx. Then solve the characteristic equation. Distinct real roots give separate exponentials. Repeated roots multiply by powers of x. Complex roots give sine and cosine, with an exponential factor if the real part is not 0. Practice a few more and you'll master the pattern.